What if I told you that less than 12 hours ago, a telescope orbiting far beyond Earth didn't just capture an image, it captured something that may force us to rethink the laws of physics. Today is February 20th, 2026, and the data sent back from the James Webb Space Telescope has shaken the foundations of optical science. For months, astronomers have been tracking an object known as 3I Atlas. It appeared ordinary at first. Its path was calculated, its structure estimated, its behavior assumed predictable. But at exactly 4 UTC, something happened that should not happen in nature. The sunlight reflecting off 3I Atlas did not simply scatter the way it does from comets or asteroids. Instead, the electromagnetic waves shifted orientation by precisely 90 degrees. In natural conditions, light scatters randomly. When sunlight strikes a comet, it reflects chaotically in all directions. That randomness is expected. It is normal. What we observed was not normal. The reflected light from 3I Atlas was perfectly polarized. It was coherent and aligned. Imagine throwing water against a wall, and instead of splashing, every droplet arranges itself into a straight, vertical line. That level of order is what we are seeing in space right now. NASA's polarimetry data revealed a Stokes parameter spike 400 times greater than any comet ever recorded. This is not dust. This is not ice. The statistical probability of a tumbling natural rock producing a flawless 90-degree polarization shift is 1 in 8.4 billion. Those are odds that demand attention. This event is happening 240 million kilometers away, and it suggests something extraordinary. 3I Atlas is not simply reflecting sunlight. It appears to be manipulating it. That distinction changes everything. Because if an object can organize light with that precision, the question is no longer what it is made of. The real question is why it would need to filter sunlight so precisely. And to understand why this has triggered emergency discussions among astrophysicists worldwide, we must first understand what polarization truly means. To understand why scientists reacted so quickly, you need to understand polarization in simple terms. Think of sunlight as waves vibrating in every possible direction. It is messy and disordered. When you wear polarized sunglasses, they block certain wave directions and allow others through, reducing glare. That filtering process creates order out of chaos. In space, comets behave like rough, uneven surfaces. They scatter light randomly because they are made of dust and frozen gases. They do not organize light, they do not refine it. But the data received at 1842 UTC yesterday from 3I Atlas tells a completely different story. When sunlight struck its surface, the waves did not scatter unpredictably. They aligned into a single plane. The degree of linear polarization for normal comets, such as Halley or Neowise, typically ranges between 1 and 3%, maybe 5% in rare cases. The reading from 3I Atlas was 87.6%. That number alone is staggering. A surface capable of that level of polarization behaves less like a dusty rock and more like a near-perfect mirror, something smooth and structurally consistent at a microscopic level. At first, scientists suspected an instrument error. The James Webb Space Telescope recorded the spike using its NIRCam instrument at a wavelength of 2.5 microns. But within minutes, the European Space Agency's Euclid mission confirmed the same signature using its VIS instrument. Then, the Very Large Telescope in Chile independently verified the optical data. 3 separate observatories, using different systems, reported identical findings. The statistical likelihood of simultaneous malfunction across all 3 is effectively 0. This qualifies as a 6 sigma event, meaning the data must be taken seriously. Then the situation escalated. 3 hours after the initial detection, the polarization angle shifted. It did not drift gradually, as you would expect from a rotating object. It snapped exactly 90 degrees in less than 40 seconds. Radar data confirmed that 3I Atlas itself did not rotate. Its axis remained stable. So if the object did not turn, what changed? The only explanation consistent with physics is that its surface actively altered the light interacting with it. And that realization opens a far deeper question. If the surface of 3I Atlas is actively altering light, then we are no longer observing passive reflection. We are observing control. In nature, certain materials can rotate polarized light. Quartz crystals and specific chemical solutions exhibit what is called optical activity. However, these materials are passive. They do not change behavior in real time. A quartz crystal does not suddenly decide to rotate light 90 degrees and then reverse itself moments later. What we saw from 3I Atlas was dynamic. Imagine a smartphone screen. It uses liquid crystals that align when electricity is applied. The molecules shift orientation because energy flows through the system. Without power, nothing changes. The 90-degree flip, recorded at 4 UTC, suggests that the surface of 3I Atlas responded actively, almost electrically. Comets are inert bodies. They have no power systems, no circuitry, no internal energy grids capable of adjusting optical properties on command. Yet the reflected sunlight behaved exactly as if it struck a programmable mirror. The Hubble Space Telescope's polarizers showed something even more striking. The shift occurred across the entire visible spectrum at once. Blue light, red light, and infrared all rotated simultaneously. In natural scattering, wavelengths behave differently. Blue light scatters more than red. That is why Earth's sky appears blue. But 3I Atlas altered every wavelength in perfect unison. This phenomenon is called achromatic modulation. To achieve that through random dust would require particles aligned with impossible precision over kilometers of space. The probability of such alignment forming naturally in interstellar space is effectively zero. So what could explain it? In advanced propulsion research, there is a concept known as photon recycling. A light sail spacecraft could manipulate reflected light to adjust direction without fuel. By altering polarization, momentum transfer can be controlled. If 3I Atlas is capable of such modulation, it may be steering itself. But propulsion is not the only possibility. Polarization is also used to encode information. On Earth, fiber optic systems use vertical and horizontal polarization states to double data transmission. When 3I Atlas flipped from 0 to 90 degrees, was it merely reacting to sunlight, or was it switching channels? That possibility introduces an entirely different level of concern. The timing of the polarization shift has raised even more questions. The 90-degree flip occurred precisely as 3I Atlas entered the optimal observational window for telescopes in the southern hemisphere. It happened when Earth-based instruments were watching most closely. That detail cannot be ignored. If the object were random, the shift would not align so perfectly with peak observation conditions. Yet it did. In physics, creating order from chaos represents a reduction in entropy. Entropy naturally increases. Systems become more disordered over time. When we observe localized decreases in entropy, we look for energy input and structure. The reflected light from 3I Atlas shows clear structure. The 87.6% polarization, the simultaneous spectral shift, and the cross-confirmation from multiple observatories were all documented before 4 UTC this morning. But events did not stop there. At 5:15 UTC, the Hubble Space Telescope briefly lost its polarization lock. For 12 seconds, the data stream flattened. When it resumed, the signal had changed again. The polarization was no longer steady at 90 degrees. It began oscillating. Every 2.3 seconds, the angle rotated from 0 to 90 degrees and back again. The pattern repeated with mechanical precision. This was not the smooth curve expected from a rotating asteroid. Natural tumbling produces gradual brightening and dimming, forming a sine wave pattern. The signal from 3I Atlas resembled a square wave. The polarization snapped to 90 degrees, held for 1.1 seconds, then snapped back to 0 and held again. The cycle repeated continuously. Square waves are not common in orbital mechanics. They are common in electronics and digital communication systems. When scientists see a square wave, they suspect artificial modulation. Multiple radio observatories on Earth confirm the pulsing pattern. If this is natural, it represents a previously unknown state of matter capable of switching optical properties faster than any material studied in laboratories. If it is artificial, then 3I Atlas is not merely reflecting sunlight, it is modulating it deliberately. And that realization is forcing researchers to confront a possibility few are prepared to accept. The energy required to modulate reflected light across an object kilometers wide is enormous. Achieving this naturally would demand power levels measured in gigawatts. Achieving it artificially would require technology beyond anything humanity currently possesses. Within 20 minutes of the pulsing pattern beginning, major radio facilities, including the Very Large Array in New Mexico, the FAST telescope in China, and the Meerkat Array in South Africa, redirected their focus toward 3I Atlas. When an object begins pulsing light with exact mathematical timing, the question shifts from what it is to who might be controlling it. An emergency session was reportedly held at the International Astronomical Union shortly after. The concern is not simply confusion, it is coherence. Let us review what has been confirmed. The polarization shifted 90 degrees in under 40 seconds without the object rotating. 3 independent observatories measured a polarization purity of 87.6%. The signal transitioned into a binary square wave at 5:15 UTC. The spectral shift was achromatic, affecting all wavelengths simultaneously. These are documented observations, not speculation. The remaining unknown is the source of coherence. If this is natural, then we have encountered a new macroscopic state of matter that challenges thermodynamic principles. If it is artificial, then we are witnessing technology capable of manipulating light on a planetary scale. In that case, the pulse may not be a reaction, it may be a transmission. Right now, as you are watching this, radio telescopes across the globe are collecting data. Algorithms are analyzing the signal structure. In less than 48 hours, 3I Atlas will reach perihelion, its closest point to the Sunday. Solar intensity will double. If the polarization holds steady under increased radiation, the implications grow even stronger. And if the square wave continues under intensified illumination, then we are not observing a passive object. We are observing controlled modulation. The next phase of observation will determine whether this phenomenon stabilizes, intensifies, or changes entirely as it approaches the Sunday. As perihelion approaches, the stakes are rising. The closer 3I Atlas moves toward the Sun, the stronger the solar radiation impacting its surface. Under normal circumstances, increased heating would disrupt surface consistency. Dust would scatter unpredictably. Ice would sublimate and create chaotic outgassing. That disorder would reduce polarization levels. Yet if the 87.6% reading remains stable, it would confirm that the surface structure is not fragile. It would be resilient and controlled. The square wave modulation remains the most unsettling element. A natural tumbling body cannot produce an instantaneous binary switch across its entire surface area. Physical rotation introduces gradual transitions. Mechanical movement requires time. What we observed were sharp, instantaneous shifts that resemble electronic toggling. The oscillation every 2.3 seconds suggests a repeating cycle. In communications engineering, repetition indicates structure. Structure implies design. Scientists are cautious. Public statements remain measured, but internally the debate is direct. Either we are witnessing a new physical phenomenon that demands rewriting textbooks, or we are observing engineered material beyond known human capability. Both conclusions are extraordinary. One expands our understanding of matter. The other expands our understanding of intelligence in the cosmos. As the clock counts down to perihelion, data collection continues uninterrupted. Every major observatory remains locked on target. Computational models are running in real time. If additional modulation patterns emerge, decoding efforts will intensify. The coming hours may provide clarity or deepen the mystery. What remains undeniable is that 3I Atlas is interacting with sunlight in a way no comet ever has. We are standing at a threshold moment in astrophysics. Whether this turns out to be a breakthrough in material science or the first evidence of engineered interstellar technology, it will redefine our perspective on the universe. The next 36 hours could reshape decades of assumptions. Stay with this story as new data arrives, because what we learn next may change how we see the sky forever. If you want continuous updates and deeper analysis as this unfolds, subscribe now and join the conversation as we follow every signal in real time.